In today's lecture, we are going to see what is Kirchhoff's law. There are two types of law which we are using in the Kirchhoff system. Kirchhoff law explains us the importance of voltage levels and the current levels for solving the electrical circuits. There are two types of Kirchhoff's law. One is your Kirchhoff's current law and another is a Kirchhoff's voltage law. Now let's see what exactly the Kirchhoff's current law says. In any electric network, the algebraic sum of the current meeting at a point is 0, which means that if we consider this as a point and there are current which is meeting at this point, then the algebraic sum of all those current is equals to 0. We can directly say that summation of all current meeting at a point is equals to 0. We can say this. Okay? Now, if you want to solve this equation, how we are going to do it? Now, applying the KCL. Now here, first understand that when the current goes towards the point, okay, we can call this as a incoming current. We can call it as a incoming current. And when the current is leaving from it, we can call it as a outgoing current. Outgoing current, okay. So now, when we apply KCL, what we have get I1, okay, it is entering, hence it is positive. After that, we are giving the sign of plus because what we have know that the sum of all currents plus I2. Now let's see, I2 is leaving, okay. This is entering, that's why we have given the positive sign. This is leaving, so we have to give the minus sign. Plus I3 is also leaving, so minus I3. Plus I4 is entering, so I4 is as it is plus. After that, I5 is leaving. You can see here, I5 is leaving. Hence minus I5 and all is equals to 0. Now we can submit that like I1 minus I2 minus I3 plus I4 minus I5 is equals to 0. And for solving, we can do this. I1 plus I4 is equals to I2 plus I3 plus I5. So we can say that the incoming current, okay, this current and this current is equals to summation of all outgoing current. Means incoming current is equals to outgoing current. So this is basically the Kirchhoff's current law. After that, we are going to see what is exactly the Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of all voltage draw around any closed loop circuit is equals to 0. Okay. Now, if we consider this as a circuit, here this is the loop number. This is the first loop where we have completed that loop with R1, R2 and supply voltage. Now, what is it says that the algebraic sum of all voltage drop around a closed loop is equals to 0. Now, we have this as a supply voltage. Okay. We need to find a drop across this and drop across this to calculate the KVL. Now, first of all, what we have to do? Voltage drop across R1. Or we have to find out the voltage drop across R1. So, what is the formula for that? Ohm's law. I multiply by R1. Similarly, for R2, I multiply by R2. We get the value of VR1, VR2. That means voltage drop across resistance 1, voltage drop across resistance 2. After that, we have to apply the KVL. Now, as similar as KCL, the formula for KVL is also similar. First of all, this is supply voltage, okay. Now it is going there, that's why Vs is plus. After that, plus I1, R1. Now I is entering and exiting from this point, okay. This is entering toward this point and exiting from this point. That's why minus I1, R1 plus, similarly, minus I1, I, R2 means Vs plus bracket minus I, R1 plus bracket minus R2 bracket complete equals to 0, which means that Vs is equals to I R1 plus I R2. We can say that Vs is equals to the current is common. So what we have did, we take this outside and we have that Vs is equals to I R1 plus R2. Now R1 plus R2 is nothing but the total resistance connected at a loop. Now please consider that KVL is applied only for a single loop. For multiple loops, we have to calculate the different KVL for a different loop. Okay, so this is how we can find the KVL. Now how we can say that this is proved? When this voltage is equals to this voltage, we can say that the KVL is proved. Similarly over here, when the input current is equals to output current, at that time we can say that KCL is proved. So this is the Kirchhoff's current and Kirchhoff's voltage law. Thanks a lot for listening.